In this video, we're going to fully factorize expressions by using the method completing the square. So in order to do this, you'll need to know how to complete the square, so that's the first thing, and you'll also need to know the general form of perfect square form and the difference of two squares. I'll remind you of the difference of two squares because that's what I'm going to be using in this video, so I'll just write it down and you can write it down in a purple box. Alright, so there it's written down and you can copy that down. Now let's go on to an example. We're going to factorize fully the following expressions. Now let's just look. We know it's in the form of x squared plus bx plus c. And we think of all the methods we've learnt to factorize so far. Can we factorize this using the fact that these two numbers multiply together to make two numbers that add together to make this? No. So we can't use that method. So then the only other method that we can use to fully factorize is by completing the square first. So I'm going to complete the square first. And remember, when we completed the square, I usually make it y equals and treat it as an equation. So it's y equals x squared plus 4x plus 1. And I'm going to begin by subtracting 1 to both sides. So y minus 1 equals x squared plus 4x. Now the right hand side, I can make a perfect square by adding half the coefficient of 4 squared. So I will be adding 4 over 2 squared, half of that, which is 4. So I'll be adding, so that's 2 squared, which is 4. So we're adding 4 to both sides. So y minus 1 add the 4 equals x squared plus 4x plus 4. So simplifying on the left, I get y plus 3. And on the right, I can fully factorize because it's a perfect square. I get x plus 2 squared. Now remember, when I complete the square, I need to subtract the 3. So it's y equals x plus 2 squared minus the 3. Now, let's just have a look at the difference of two squares. The difference of two squares is in the form of a squared minus b squared equals a minus b times a plus b. Now let's consider the above expression. What we have here is we have our a term. This currently isn't written as a squared term, but we can write 3 as a square root and a squared because the square root and the squared undo themselves to make 3. So I can actually write this expression as y equals x plus 2 squared minus root 3 all squared. Now you see what I've got there is that is now my b expression here. So I have a squared as in highlighted in yellow, and I have my b squared, sorry I should use yellow for that, not blue, apologies, a squared, and then b is my highlighted in blue. So I can now write this as a difference of two squares, which will then make this expression from completed square to fully factorized form. That becomes x plus 2 squared minus root 3 all squared equals x plus 2 minus root 3. I'm going to have to move this along a bit, multiplied by x plus 2 plus root 3. Okay, now let's do another example where I'll use the same method. So I'm going to fully factorize this expression. Y equals x squared minus 8x minus 3. Now, the first thing I'm going to do is complete the square. Now, if you've watched the above example and the video on completing the square, you will find that you get y equals x minus 4 all squared minus 19. Now, that's now in completed square form. Now, let's write this so that we've got a and b. So I'm going to write y equals, this is my a term, x minus 4 all squared, and then my b will be square root of 19 all squared because that's just 19. So what I've got here is my a and my b. So if I write that in terms of the difference of two squares, I've got my a squared minus b squared becomes a minus b times a plus b. Let's substitute our a and our b into this expression, and this is what we get. I get that x minus 4 all squared minus root 19 all squared equals x minus 4 minus root 19 multiplied by x minus 4 plus root 19. All right, let's do another one now. So I want you to consider the expression y equals x squared plus 2x plus 8. Now, what we do is we cover all lines. Can we factorize this expression using the above method, completing the square? If we can't do it by the other method, remember the method where you find two factors of 8 that when multiplied make 8, when added make plus 2. If you can't do it that way either, the only method to go for is by trying to complete the square and seeing if you can get the difference of two squares. So I'm just going to write this in in completed square form. So I get x plus 1 all squared plus 7. So if you were to work through that and complete the square of that expression, this is what you would get. Now, is this in the form of the difference of two squares? No, because of this plus sign here. Remember, the difference of two squares involves the first term squared minus the second term squared, so it is not in that form. We can't factorize this using perfect square method either, because this part here is the perfect square and we have the plus 7. So it can thus be finalized to say that this expression cannot be factorized in any of the methods that we've used. Okay, now the only other example I want to go through is when you've got fractions. So I will work through how to do this as completed the square. So here's the expression at the top. I've put it y equals. So the first thing I'm going to do is subtract the half from both sides. So I get y minus a half equals x squared plus 3x. Now I want to make the right hand side into a perfect square. So I need to add half the coefficient of the x and square it. So I will be adding 3 over 2 squared, which is 9 over 4. So I'm going to add 9 over 4 to both sides. So I get y minus a half. I'm going to make a half 2 over 4, so it's easier to add. So I'm adding the 9 over 4, and to the right hand side I get x squared plus 3x plus 9 over 4. Now the right hand side is a perfect square, so that is factorized as 8 plus 3 upon 2 squared. And the left hand side, now it's easy to simplify because I've made the denominators the same, is just y plus 7 over 4. And to make it in completed square form, I'm going to subtract that 7 over 4 to get y equals. So I get y equals x plus 3 over 2 all squared minus 7 over 4. Alright, now the next stage is to turn that into the difference of two squares. We can see it's the difference of two squares because that will be my a term and this is going to be my b term. But obviously I need to square root and square that term. Alright, so I'm just going to make that the square root of 7 over 4. For maths method students, that's okay to leave it like that. So that just becomes x plus 3 over 2 minus the square root of 7 over 4 multiplied by x plus 3 over 2 plus root 7 over 4. Now if you do the Maths C aspect, you will know that root 7 over 4, and again this is not relevant for maths methods people, but this root 7 over 4 can be written as root 2. So I'll just recall that can be written as root 7 over 2. So if I'm going to fully factorize this, I can say that x plus 3 minus root 7 over 2, because that will give the same denominator as that, simplifying that fraction, and that becomes x plus 3 plus root 7 over 2. Okay, which actually breaks it down into two terms, which makes it look much nicer.